Okay.
Hi.
Hi guys. Good morning. We're kind of kicking it old school today. No fanciness. We're just going straight at it.
That's right.
Yeah. So we're going to talk about balancing chemical reactions and then the whole law of conservation of mass.
Okay.
All right. So first, conservation of mass. Well, what really is it? It means matter cannot be created or destroyed. It's just rearranged in a different form.
Okay, so the amount of stuff I start with, I have to end with the same amount of stuff.
Exactly.
Okay.
So whatever I start with, you got to end with. Now, it's not going to look the same, obviously, but the mass, the product, the numbers, they should all match up.
Okay.
Okay, so there you can see an example. Reactants is equal to what the products are going to be. And then we have the salt example that we've been kind of working with already.
Okay, so I have two sodiums on one side, two
sodiums on the other.
Might look different, might act different, but same elements on both sides.
Okay, so we're just going to talk real quick before we get into the, I don't know, what are you on? Bread and potatoes?
Sure.
Meat and potatoes? Of balancing. There's some special elements, and they are called the diatomics. They are, whenever they're written by themselves, so like if I have hydrogen or oxygen, they always have a 2 because they bond to themselves.
Okay, so naturally occurring, they always are just paired up.
Yes. So a simple way to remember them is NO, nitrogen, and then the halogen group.
Okay, so HEC is hydrogen.
Correct.
NO is nitrogen, oxygen, and then all of my halogens.
Yes.
Okay.
And you can also see, I like to call them the magic 7 sometimes just because it makes a 7.
That's cute.
I know, it's very, Disney-esque. All right, so let's get right after it. So we're going to start with balancing the first one here. Well, we have our Ca plus O2, one of our diatomics we just talked about, and it produces calcium oxide.
Okay.
All right, so what I like to do first is, and I don't know, maybe Mr. Wood's a little different, but I like to write the elements involved right underneath it.
Totally. Love doing that.
Yeah. Okay, so I look on both sides. I have 1 calcium to start, so I write Ca, obviously, and 1 on each. Then I write O, and I count up on both sides. So on my left side, I have 2. On my right side, I only have 1.
Okay.
Okay, so I know I need to fix that right off the bat.
So, because 1 oxygen is being destroyed, I start with 2, end with 1. They've got to be the same number of both sides.
Yes, so something is clearly
Not good.
incorrect.
Yeah.
Okay, now the only thing I cannot do is I cannot add subscripts.
Okay.
So I can't do the little numbers. I can only put big numbers in front of things.
Okay.
Okay,
All right.
so
sure.
I'm not Bill Nye. I'm not, magical like he is.
Sure, yeah. You can only add coefficients in front. Got it.
Exactly. So I have a rewritten equation. Okay, so I'm going to start by putting a 2 in front of the CaO on the right side.
Okay, so I need 2 more oxygen. So I need another oxygen on the right side. So I put a 2 there because 2 times 1 is 2.
Correct.
Now I have 2.
Yes.
oxygens.
So then again, I have my rewritten elements involved. So I have 2 calciums now and 2 oxygens. So I got my oxygens balanced.
Boom.
But now I screwed up my calciums.
Okay.
So now I have to go back to the other side and figure that out by putting a 2 in front of Ca. And now when I do my little atom count, if you can see, we are perfect.
Got it. Okay, so I had to add the 2 in front of the CaO, but that messed up my calcium, so then I have to add the 2 in front of the calcium. So, okay. So I can see where it can get pretty complex here.
Yeah. So that's one example. Here's another one for you. Okay, we have Na plus water yields NaOH plus H2. Again, another diatomic, so it's written
Oh, fun
by
stuff.
itself. So I start with my atom count. Na's, 1 on each side. H's, 3 on the right, 2 on the left. God, I hate those
Okay.
odd numbers.
I know.
Okay, and then I have 1 and 1. So my first fix, I'm going to fix the one that's clearly incorrect.
So I don't have enough hydrogens on the left side.
Correct.
So I have to add more hydrogens on the left side, right?
Right, but what I did here, because I like to work with even numbers, is I put a 2 in front of NaOH.
So what you do first is make everything even?
I try to make it even, so it's a little easier to work with even numbers.
Okay, even or 1, I guess.
Yes, right. So I put a 2 in front of NaOH, which then changed my atom count. Now I have an even number of hydrogen to work with, which is kind of nice.
Yeah.
Okay. So now I have 2 NAs and 1 NA and 4 hydrogens and 2, but these are all nice numbers that I can work with a little bit.
Yeah, you can manage those. Okay.
So then I put a 2 in front of Na and a 2 in front of H2O.
Because
on the left.
I need twice as many of everything on the left side.
Yeah. Okay, so then I did my atom count again, and ta-da.
Wow.
Okay?
Look at that.
Yeah. So it's always easier to work with even numbers, I think.
Okay.
And then I can go back and check and make sure that I can not reduce it anymore.
Okay, so the first thing you do is you add up all your atom counts on both sides. The second thing you do is make everything either an even number or 1.
Right.
And then the last thing you do is change whatever you need to change to get them to be the same.
Exactly.
Okay.
Okay, so here's another example. which I'm going to do on the board because I didn't want to go through the
Sure.
animation. It was a little bit crazy. So I have C2H6 plus oxygen yields carbon dioxide and water. Okay? So C, H, and O. All right? On this side, I have 2 C's, I have 6 H's, and 2 O's. So far,
Okay.
so good. On this side, I have 1 C, 2 H's, and 3
Oh, boy.
O's.
Okay.
Okay? Now, these combustion ones, okay, the ones that you have only C, H, and O, are usually a little tricky.
They are. They can
Okay.
get a little.
Mr. Wood, do you have any tips? What do you do with
Okay.
the combustion reaction?
So pretty much, I do exactly kind of what you say. I
Okay.
make it even and I balance them out. There's a couple of tricks when it gets really, really hard, and you end up with like weird fractiony stuff. But
Yeah.
let's tackle that when we get here.
Okay. So, what do you want to start with?
So okay, well the first thing I want to do is I want to make. I see my O's have an odd number,
Okay.
so I want to make my O's even.
And I'm going to switch colors just so that we can see a little bit better. Okay.
Okay.
So, I'm going to make my O's even. So, I have 2 here and only 1 here. So, I'm going to put a 2 in front of this guy to make, now I have 2 here plus these 2 gives me 4.
Okay.
Okay. And now I have 2 times 2 for hydrogen, which also gives me 4.
Okay.
All right. Then I'm going to look and see, oh, well, my carbons aren't right either. So, I might as well make that a 2 as well. But, what does that now do?
Oh boy, that messes with my O's again.
So now I have 2 times 2, which is,
4,
and then plus another 2, which is
6.
okay. All right. So, well, that worked out nice, except now my hydrogens are
Or-
off.
Yeah, that's
Okay.
crazy.
So
Okay.
I needed to get to 6. So I'm gonna try and do something fancy and do this. I'm gonna change that to a 3, which now gives me 6 for hydrogen.
Mhm.
But now I have 3 plus 4, which
oh,
is
jeez, gives me 7.
9.
Oh boy, this is a mess.
Okay, you'll learn that through balancing equations, it's a lot of trial and error.
It is. Yeah, it's a lot of playing around. It's a game.
It's kind of fun.
Mhm.
You'll like it. All right. So now what do we want to try? Can I take anything on this side times 2 to give me a 7?
3.5.
Except that's all got to be
Yeah.
whole numbers,
Oh.
so that's not going to work. So what should we try? You think?
Well, I have a trick.
Okay,
You
what's
wanna
your
see my
trick?
trick?
Yeah, let's see your
so
trick.
what my trick is,
Okay.
let's say I put a 3.5 here, because 3.5 times 2 is 7.
Right.
Well, I can't have a half number, right?
Correct.
So, but what I can do then
Mm-hmm.
is if I multiply everything by 2, that turns it into a whole number. So what I do here is I'm going to
Oh, okay.
multiply all my coefficients by 2. So I do a 2,
2.
3.5 becomes 7.
Okay.
This 2
Becomes a 4.
becomes a 4, and this 3 becomes a 6.
Sorry for the stretch. I could
yeah, I
have
know.
I could have taken the marker from you,
If I
but
stand up, I could get my head cut off. So that's
Yeah.
good. And then
go back and count.
go
right?
back and count. So 2 times 2 is 4.
Okay.
4 times 1 is 4.
Oh, perfect.
Yeah, like that.
Yeah.
2 times 6 is 12.
All right. 6 times 2 is 12. Okay.
Okay. Now we might need to change the balance a little bit here, but
Okay.
we have
7 times 2 is 14.
14,
Okay, now this is where it gets tricky because we're split up again.
Mhm.
So I have 4 times 2, which is
8,
plus another 6, which is
14.
wow, nice. And just like that, now the last thing I like to do is I just look back. Can I take any of these numbers and divide them all by the same to make it smaller?
Mm-hmm.
And as you see, we cannot do that, so we are good
Done.
to go. Okay? So the last thing we have for you is just a few little reminders. Okay?
Mm-hmm.
It's always trial and error.
Yep.
Okay, and you always want the simplest ratio. So even if these numbers are doubled, that's okay that you figured it out that way. But then, get them back to where they need to be. I always leave oxygen last.
Oh, it messes things up.
If
You
you try
got
to
it.
balance oxygen first, it's like then you're off your
Oh,
rocker. So
yeah, oxygen's
it'll
horrible.
drive you nuts. So leave oxygen to the end. Try to use even numbers, and then I like to save these ones like by themselves for last because that's easy. Just put a number right in front.
Sure,
and it only
exactly.
affects that. element.
Yeah. There's no
So-
little trickle down effect.
Right. So, well, that's all we got for you. We'll take lots of practice time in class.
You know it.
See ya.
Bye.